Hello students, today we are going to discuss about a new chapter, that is, in today's world we use different things, okay, that are made of rocks. So where do these things come from? Let's begin with. It can be a pen, or it can be your motorcycle, or your toothbrush, toothpaste, or maybe your bicycle. Okay, so let's begin with chapter number 4, Mineral and Power Resources, class 8. So the economic and industrial progress of a nation depends mainly on mineral and power resources. Their distribution is highly uneven. I mean to say that, let's take example of Assam. Assam is rich in vast oil reserves. Okay, Assam is rich in vast oil reserves that is not available in some other parts of India or even in the world. Okay, so in the same way, Chhattisgarh is rich in high iron ore reserves, whereas Assam lacks in these reserves. So that is their distribution, mineral distribution is highly uneven. A mineral is a naturally occurring substance found in the earth's crust. Silicates like feldspar and quartz are by far the most commonly available minerals. That is silicates. Okay, silicates. They are available in almost all the parts of the world. Okay, so these are commonly available minerals, followed closely by aluminium, iron and calcium and many more. A rock. Let's talk about a rock. As I have already in the introduction I told you that we use different kinds of rocks. So let's see where do these rocks come from. So what is a rock? A rock which contains enough mineral to make it economically viable for mining is called an ores. Okay, so rock is composed of different minerals. Okay, so these contain mineral which is economically very important for a nation to develop. Okay, and it can be extractable from the help of a process called mining. Okay, so ores are classified as high grade and low grade ore afterwards. First of all, we need to mine it, this type of rocks which are needful or which are important for uh, extraction of minerals. Then afterwards we used to look after that which grade does it. So is it high grade ore or is it low grade ore? So high grade and low grade ore is the classification of rocks. High grade ore and low grade ore. This is the classification for a rock. Now let's talk about the types of minerals. That is the classification of minerals. Types of minerals or classification of minerals. That is metallic and non-metallic. Metallic and non-metallic. Metallic and non-metallic. So metallic and non-metallic, I hope you already know about it. That is, in your science, you could have already studied about the types of minerals, that is metallic and non-metallic. Metallic means it has more metal properties. like iron. Okay, it has some shine, that is luster, and it is made up of igneous and metamorphic rocks, whereas non-metallic does not have sign. They are like limestone, mica, gypsum, coal, petroleum, and they are mostly made up of sedimentary rocks. Non-metallic minerals, they are mostly composed of sedimentary rocks, whereas metallic minerals, they are mostly composed of iron, that is igneous and sedimentary rocks. Okay, now within metallic you have two classification, that is, one is ferrous, another is non-ferrous. So ferrous, non-ferrous. Ferrous means which is which contains iron. Okay, mostly iron, that is iron, manganese and all. Non-ferrous examples, if you could see, gold, silver, and copper were the best example for non-ferrous metallic minerals, whereas ferrous metallic minerals only contains the iron. Okay, iron, manganese. So now, how are minerals classified, or how are minerals extracted first? How are minerals extracted? There are three basic types, okay, for extraction of minerals. That means minerals can be extracted, need to be extracted, then only we will get this kind of things which we are using in today's life. Okay, it may be your mobile phone, it may be a camera, or it may be anything which we are using from morning till night. That is, for extraction of minerals, there were three process. One is mining, another is drilling, another is quarrying. Okay, mining, drilling and quarrying. These were the three process through which we used to get we can extract minerals from earth. Okay, so first understand mining. Okay, mining means taking out minerals from earth. Okay, so this mining has two other classification, that is, one is open cast and another is shaft. One is open cast and another is shaft mining. Okay, so open cast means, suppose this is the earth and a particular mineral is very near from the earth. Okay, from the earth it is very nearby, it is shallow, I mean to say shallow, at shallow depth. Okay, shallow depth means very nearby to the earth surface, very nearby to earth surface. So this can be done by digging holes here and can be taken out through open cast. Okay, but whereas in this type of mining, shaft mining, what happens, this is the earth surface and the particular mineral is at greater depth. Okay, here the mineral is there. So as it is in a greater depth, so in this we use shaft mining. Okay, that is those who are far away from ground. So when a mineral is far away from the ground, we use shaft mining. When a mineral is near by the earth surface, then we use cast mining. Okay, so now drilling deep wells are bored. So good example is taking out of oil. Okay, crude oil from the earth's surface. Okay, below the earth surface we drill and we take out oil. Then quarrying means whatever mineral available in the surface of the earth, that is quarrying. Okay, so minerals near the surface are dug and quarried away, like stones and all, quarrying. Okay, so we used to take stones from the rivers. Okay, so for making for the construction of homes and buildings. So what do the dumper used to do? They used to quarry the stones and sand, whatever is needed for the construction of our homes or buildings. That is it. Now let's talk about distribution of minerals. So regarding distribution of minerals, you could see iron ore is there. Okay, iron ore is available in North Sweden mostly, whereas in India, if you see, Chotanagpur Plateau is there in India, which is very rich in iron ore, whereas limestone deposit, if you see, it is mostly available in France, that is Caucasus Mountains, whereas manganese deposits in Ukraine and Georgia, copper deposits in Canada. Okay, so these things were there, you could see in that book. So now let's see the distribution of minerals in different continents individually. Asia, let's take example of Asia. Asia, 50% of the world's tin production, that means half of world tin production is done in Asia. Half. Half of tin production, that means 50% of world's tin production is only in Asia, one single continent, that is Asia, and other half, 50%, goes to all other continents. Now let's take example of China and India. China and India is the leading producer of iron ore. China and India is the leading producer of iron ore, which is also in Asian continent. Then tin, China, Malaysia, Indonesia and many more countries were there who produces tin, whereas China leads in lead, antimony, tungsten, etc. Okay, that is about Asia. Now let's talk about Europe. Europe means leading producer of iron. Europe is the world's leading producer of iron. Then within here Switzerland is there. Switzerland is there. Here there is no mineral deposit available, whereas Europe is the world leading producer of iron. Then Russia, Ukraine, Sweden, France, they were also very rich in iron ore. Then Eastern Europe and European Russia, copper, lead, zinc, manganese and nickel were available there. Now let's talk about North America. So North America, if you see, Canadian region, okay, Canadian region north of the Great Lakes, known for iron ore. Nickel, gold, uranium and copper were also available there. Then Appalachian mountains and regions of Appalachian were very rich for coal deposits. Then mountains ranges of the west, famous for copper, lead, zinc, gold and silver within North America. If you go to South America, Brazil is the largest producer of high grade iron ore. Chile and Peru were rich in copper, whereas Brazil and Bolivia rich in tin. Venezuela, Argentina, Chile, Peru and Colombia were very rich in oil deposits. Then let's talk about Africa. Largest producer of gold, platinum and diamonds. South Africa, Zimbabwe and Zaire, gold. Green diamond is the rarest diamond available in Africa. Now Australia, largest producer of bauxite. Kalgoorlie and Coolgardie were very rich for gold deposits. Gold, diamond, iron, etc. is also available in Australia. Now finally to Antarctica. Antarctica, is a cool place, whereas even if it is a cool place, coal is available in Transantarctic mountains. That means connecting with other areas. Transantarctic means connecting with other continents. So within those mountains you could see coal deposits were there. Then iron in East Antarctica is also available. Now if you see minerals in India, like iron Iron is available in Jharkhand, Odisha, Chhattisgarh, MP, Goa, etc. Bauxite is available in Jharkhand, Odisha, Chhattisgarh, etc. Mica is available in Jharkhand, Bihar, Andhra Pradesh. Copper is available in Rajasthan, Madhya Pradesh, Jharkhand, etc. Manganese is available in Maharashtra, Madhya Pradesh, Chhattisgarh, etc. Limestone is available in Bihar, Jharkhand, Odisha, Madhya Pradesh, etc. Gold is available in Kolar in Karnataka, whereas salt, one of the world's leading producer and exporter, is India. That is, we used to get in Sambar Lake. Then silicon, that is Himachal Pradesh and Madhya Pradesh. Now let's talk about the conservation of minerals. Minerals take a very long time to develop, and as it is taking long time to develop, so they cannot be replenished easily, it means, okay, and immediately. So what is our duty? It is our duty and our responsibility not to misuse it and to conserve it, okay. So these are these things for minerals. Now let's talk about the power resources. Power resources are classified into two. One is conventional, another is non-conventional. Conventional means traditional, okay. So those resources which we were using it from a very long time, okay. So you just keep it, you just uh, have some idea regarding that, I hope so, because conventional sources of energy were traditional sources of energy. It means that firewood which we were using, not only we but our forefathers were using it for cooking food and for various purposes. So firewood is widely used for cooking and heating, and more than 50% of the energy used by the villager comes from the firewood. That is a conventional uh, source of energy, firewood, okay. Next comes is coal. Coal, coal is one of the most important minerals. It is mainly used in the generation of thermal power. That is coal. In India, coal is mostly found in Jharkhand, as I have already told you, West Bengal, Odisha, Chhattisgarh. The next comes petroleum. Petroleum is also a conventional source of energy. Petra means rock, oleum means oil, that means it is rock oil, okay. It is rock oil. It is also known by different names like black gold and liquid gold, because it is very valuable, so that, okay. So these were the conventional resources. The next is the natural gas. Natural gas also available nearby the crude oil only, okay. So this gas is released when crude oil is drilled, and the natural gas is brought out on the earth's surface. So natural gas can be used as a domestic and industrial fuel. And in India, GAIL, Gas Authority of India Limited, looks after all the natural gases available within the political boundary of India, okay. It was set up in 1984, and it is a public sector industry. So Krishna Godavari Delta is very famous for natural gas. Not only that, Tripura, Jaisalmer, and some parts of Mumbai, Maharashtra will also can be seen about natural gas reserves. CNG is also a part of it. So now let's talk about the non-conventional sources of energy. Non-conventional sources of energy are those that are continuously renewed, okay. So like, which are those energy which can be renewed? They are solar energy, okay. Solar energy can be renewed. Then wind energy, okay. Wind energy can also be renewed. Not only that, bioenergy from biofuels, hydroelectric power, geothermal energy, these are the things which can be renewed. They are non conventional source of energy. The main advantage of non-conventional source of energy is they are non-polluting in nature. They are polluting in nature. If you burn this gas, if you use these things, if you use these sources of energy, you will get pollution, okay. Whereas if you use this type of energy which is non-conventional, then you are not going to get any pollutant. Okay, so let's discuss through this. The first to discuss is the hydroelectric power. So water from rivers and rains is stored in dams, and this water falls from greater heights onto turbine blades, making the turbine move. And once the blades rotate, what happens? The rotating blades turn the generator to produce electricity. This is called hydroelectric power, that you can see on your book. Then solar energy, you can see solar energy is the energy obtained from sunlight, and the two effective process to tap solar energy is the photovoltaic cells. One is photovoltaic cell, another is the solar thermal technology. Sun rays are trapped in photovoltaic cells, they are converted into electrical energy. That is the solar energy. So you might have seen in somebody's home that solar panels were there, and through that panel solar is produced, solar energy is produced, electrical energy is produced. So now let's talk about the wind energy. Wind energy is also pollution free, inexhaustible source of energy. In this the kinetic energy of wind is converted into electrical energy through turbines, like windmills. Windmills you could see in many of the places where in Tamil Nadu and all, that they used to rotate, and when they used to rotate they used to produce electricity. So the wind are very stable there, so that they were set up there. So Netherlands, Germany, Denmark, UK, USA are there where this kind of windmills were set up. In India, Tamil Nadu is a good example. Then let's talk about the nuclear power. Nuclear power. Naturally occurring radioactive nuclear minerals like uranium and plutonium are the sources for nuclear power. These fuels undergo nuclear fission in reactors and emit energy. The leading producer of nuclear power are USA and France. Okay. In India, Rajasthan and Jharkhand have large deposits of uranium. Thorium is found in large quantities along the beaches of Kerala. Okay, so these were the things. Another one is the geothermal. Geothermal energy. So geothermal energy are like natural geysers. You have geysers at home, so in the cold season what you used to do, you used to put on the geyser and used to take hot water bath. Okay, in the same way our earth produces this kind of hot water from the earth's surface. So heat energy obtained from the earth is called geothermal energy, and the hot water that gushes out through natural geysers or geothermal springs is used to produce thermal energy. So a good example is given here. It is used for cooking, bathing and other all things, washing and all. So Puhagan geothermal plant, Philippines is a good example for it. And if you talk about Assam, within Assam there is one Garam Pani in Golaghat, that is a good and great example for geothermal energy. Let's talk about tidal energy. Tidal energy you will not understand till you do not visit any area which is very nearby to oceans. Okay, so energy generated from tides is called tidal energy. So tidal energy is harnessed by building dams at narrow openings along the tidal belts of a sea. So wherever the level of ocean rises up or goes down. So during high tide, the energy of the oceans, the tides, is turn the turbine installed in the dam to produce electricity. Okay. So Russia, France, and in Kutch, Gujarat, Gulf of Kutch in India have huge tidal mill farms. Then biogas is there. Biogas is also a good alternative. It is energy generated from dead and decayed matters, organic matters. Okay, and it is an excellent fuel for cooking, for domestic lighting in rural areas, and for producing organic manure. So whatever is used, a whole type will be there, and within that we will put all the organic matters, and later on from where the gas will come out through the pipe, we used to connect it into the gas stove and we will burn it. After we use all the decayed matter, all the decayed matter need to thrown out. So what we will do, we will take it out and we will use it as fertilizer in the fields. Okay, so rice fields and all. That is very useful, biogas. So biogas plants were available in almost all parts of India. Then regarding save energy, while we should make every effort to conserve untapped energy resource, it is equally important not to waste the energy that is already harnessed. So it is our duty to protect, to save the energy, and so that we can use it in the near future. Okay, so take the responsibility and save energy. Thank you very much.